To explore more ideas on designing recursive methods, we have seen methods that do not retain any value as void methods, and also we have seen examples on methods that retain a value. Now this time we would like to show you how to design a recursive method that deals with arrays. And here is one of the examples. It says write a recursive method called arraySum that retains the sum of the elements of an integer array if the array is passed as an input parameter to the method. So we have already implemented a recursive method that finds the sum, but the input parameter was an integer n, and the method was finding the sum from 1 up to n. But this time, this method is required to find the sum of the elements of the array. So the design is a little bit different than the design of that method. So let us think about on how to design the recursive method. Remember that to find a solution, or if you want to design a recursive method, then you need to split the entire task of the problem into a subtask with a smaller input. So for example, if we have the following array, and it consists of only 4 elements. So in fact, we want this method to find the summation of A0 plus A1 plus A2 and plus A3. So our discussion is, what will be the input parameters to this method? Is it enough just to pass only the array, or we need more parameters to pass to help us design the recursive method? Now for finding the sum of all elements of this array, then we need to add A0, A1, A2, A3. But if we want to think recursively and we want to use the same method for finding the sum of part of the array, then maybe we can think about an array of a smaller size. Now since the size of the array is 4, and the method is in fact finding the sum of all the elements of this array, so how to think recursively and make the same method find the sum of part of the array? So if this is of size 4, and how about if we make the same method finds the sum but not from A0 up to A3, we wanted to find the sum of the elements from A0 up to A2. So here we are talking about an array of size 3. So the original method was working on the entire array of size 4, but we want to make it recursively work on part of the array and of size 3. So therefore, we don't want just to pass the array as an input parameter. We need also to pass the size. So to solve this problem recursively, we need 2 input parameters. One is the array, the other one is the size. So why we need the size as an input parameter? Because when you call the method recursively, for the next calls we have to make the size of the array smaller, so that we break the array into smaller arrays until we reach the base case, and then when we return back from the call of the method, we keep adding those elements recursively. So therefore, for every call of the method, we need to pass a size of the array less by 1, so that we can find the summation of all the elements recursively. So for the first call of the method, we pass the array as well as the length of the array. For our example here, the length is equal to 4. So the method is supposed to find the sum of the elements A0, A1, A2 up to A3. Notice here that we are dealing with arrays in Java, and arrays in Java, the indices always start from 0, and the last element, if the array size is 4, then the last element will be at index 3. So therefore, when we call the method sum A4, it is going to find all elements up to A3, which is 4 minus 1. Now if we want to think recursively, and we would like to use the same method but with a smaller size of an array, then we can look at it recursively by saying that the first elements of the array, excluding the last one, can be obtained by calling the method, but this time with an array of size 3. So for sum A4, we can call sum A3 and the returned value is added to A3. And now for sum A3, in fact, it's supposed to add the elements A0, A1 up to A2. So if we have an array of size 3, then the last element will be at index 2. So and again, if we want to think recursively for sum A3, A0, A1 can be obtained by calling the method, but this time with an array of size 2. And for calling the method with an array of size 2, it's going to retain the sum of A0 plus A1. And if we have an array of size 2, then the last element will be at index 1. So for A0 also can be obtained by calling the method, but this time with an array of size 1. And when we call the method with an array of size 1, we have only one element. So therefore, the method is supposed to retain this only element without calling the method again recursively. Since the last call of the method did not call itself recursively, then it is considered as the stopping condition or the base case. Now, if you want to show that this recursive calls of all of these methods really find the sum of all elements of the array, do back substitution. So the return value from calling the method A1 in the previous step, replace it by A0. So for sum A2, in fact, you are adding A0 plus A1. And now for sum A3, replace the return value of sum A2, and the return value for sum A2 is A0 plus A1. So substitute it back, and in fact for sum A3, you are adding A0 plus A1 plus A2. And finally, replace the return value from sum A3, which is A0 plus A1 plus A2, and then add it with A3, and in fact you are adding the whole elements of the array. Now to generalize the call, suppose instead of 4 we have n, which is the size of the array. Then how to express the call recursively? You say sum a of n, and now you need to call the method recursively, but the size should be shorter by 1. So if the input is n, then you pass n minus 1. And finally, you add the return value of sum a n minus 1 with a n minus 1. Why? Because if the input is n, the last element will be at n minus 1. So we will have here a n minus 1. And this is how we write it recursively. We say sum a comma n is equal to sum a n minus 1 plus a n minus 1. To implement this recursive design in Java, we use if statement. We start with the base case. If the input parameter n is equal to 1, which is the base case, then it retains the only available element in this array, which is A0. Otherwise, we call recursively according to the expression we have here. We call the method recursively, but passing n minus 1 as the size of the array, plus the last element of this array, which is a n minus 1. Now we are in Java. We would like to test our recursive algorithm that finds the sum of all elements of a pass parameter array. First, we need to define the array. We are going to define it as a private, because we are going to call it within the class. Static, because we are going to call it from main, and main is a static, and it is going to return an integer, and the name of the method is sum, and the input parameter will be an array of integer that is called a, and at the same time we are going to pass the size, and the size will be called n. According to our design, first we need to check for the base case. So if num is equal to 1, then we are going to retain the only element in the array of size 1, that is A0. Otherwise, we are going to call the method recursively. Since the method retains a value, so we have to say return, and now we call the method. But this time we have to pass the size n minus 1. And then the return value is added with an minus 1. And this completes the implementation of the method. Now we need to test the method by calling the method with a sample of an array. We are going to define an array of integer that is called array, and we are going to put inside it the constants 3, 5, 9, and 6. Then we are going to print the return value. When we call the method, we will say system.out.println, and we will say sum is equal to, and now we will call the method by saying sum, and we give the name of the array we defined inside main, followed by the size. We say that array.length. So now the program is complete, so we will run it for testing. So we have a syntax error. Yes, the input parameter is n, but here I called it num, so I'm going to remove num. Run it again. And it is printing the sum correctly because 3 plus 5 is 8, 8 plus 9 is 17, and 17 plus 6 is 23. So the program or the recursive method is working correctly.